Assalamualaikum and hi students. So this is a lecture video for BMCG 1013 Differential Equations. So for the first chapter, we have a chapter on first order linear differential equations. At the end of this lecture video, the student should be able to describe the basic concept of differential equations, to classify the differential equations and to solve two equations from first order differential equations, which are separable and linear equations. In 1.1, we have introduction to ordinary differential equations, or we call as ODE. Okay, so what is differential equation? It is an equation relating an unknown function and one or more of its derivative. And then we have two types of differential equations, which are ODE, ordinary differential equations, and PDE, partial differential equations. So ODE is an equation contains only ordinary derivative of one or more dependent variables with respect to a single independent variable. While for PDE, partial differential equations is an equation involving partial derivative of one or more dependent variables of two or more independent variables. So that's the difference. In ODE, we just have a single independent variables, but in PDE, we might have two or more independent variables. Or we can say ODE normally denote as dy over dx. Or we have df over dt. We use d. But for PDE, we use del u over del x, or del f over del z, for example. In example 1.1, determine whether the following equations is ordinary differential equations or partial differential equations. So basically, we just need to refer to the d or del. Okay, so in A, we have x d square f over dx square minus 4x plus 1 df over dx equal to 3 sine 2x. So in the first glance, you know you have d here. So it is an ODE, ordinary differential equation. Second, we have B, 4x square d square y over dx square minus 8x dy over dx plus y equal to 0. It is an ODE. Okay, and then C, we have del f over del x plus del f over del y equal to 2x square plus 3 plus y square. So this is PDE, since it used del f. Okay, and then the last one, obviously it is a PDE, partial differential equation. Simple. Okay, next we have the order, linearity and homogeneity of ODE. Okay, so basically the variables with respect to which differentiations occur are called independent variables, while those that are differentiate are dependent variables. Or in simplest word, you can say that independent variables are the denominator and the dependent variables are the numerator. Okay, so if you have, okay, let's see this example 1.2 here. Write down the dependent variables and independent variables of the following ordinary differential equations. So A, you have x d square f over dx square plus 2x of 2x df over dx equal to sine x. So this is your numerator. So the numerator f is your dependent variable. Okay, and then what is your denominator? Denominator is x here. So x is independent variable. Okay, moving to B, you have 3 dx over dt minus 3 dy over dt plus cos t. Okay, so for dependent variable, dependence dependent variables, you have x and y. Okay, because numerator you have x, another numerator is y, and you have one single independent variable, which is which is t. Okay, this is the independent. And the last for C, we have independent z and dependent u and f. Okay, so that's the difference between dependent and independent. As for the order, we have the order of a differential equations is the order of the highest derivative. The order of the highest derivative that appears in the equations. The order of an equation is not affected. Okay, it is not affected by any power. Okay. Example 1.3, determine the order of the equations below. Okay, so A, you have 4 dx over dt minus 3 dy over dt plus 2x minus y equal to 3 sin t. So the highest power here, the highest order here you have 1. So for A, you have order 1. Okay, and look at B, you have d square f over dx dy plus 2x df over dx equal to x square minus 2y plus x. So between these two, d square f and df, so this is the highest order. So for B, we have order 2. Okay, but for C, you have d cube y over dx cube equal to dy over dx to the power of 4 plus 4x. So the order for C is order 3 and not order 4, because this is just the power. And again, the order is not affected by any power. So meaning that you cannot consider this 4. Okay, so the order for C is 3. For the linearity, the equation is said to be linear if, okay, you need to consider these 3 conditions. The first condition is the dependent variables and their derivative do not occur as products. Okay, so you need to define what is your dependent variables first. Okay, and then second one, the derivative do not raise to power. Okay, and the third one is the dependent variables are not in nonlinear functions. So if it holds all these 3 conditions, so it is a linear equation. If the equation is not linear, it is called non-linear equation. And this is the general form for linear equation. Okay, the general form for linear equation. Okay, the notes here. So first we have the dependent variables y of the dependence variable y and all its derivative y prime, y double prime until yn are of the first degree. That is, the power of each term involving y is 1. So this reflects to the second condition. Okay, the derivative must not raise to power. Okay, and for the second one, the coefficient a naught blah 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 an of y prime to yn depend at most on the independent variable x. Okay, so meaning that the dependent variables and the derivative do not occur as products. Okay, but if it's a product of independent variable and its derivative, it is okay. To understand more on this linearity, we have these 5 examples here. Example 1.4, determine whether the following equations is linear or non-linear. So refer to the 3 conditions. Okay, so for A, you have d square f over dx minus 5x df over dx equal to cos pi x. So for the first conditions, the dependent variables and their derivative do not occur as products. So there is no products of dependent variables and the derivative. Okay, first, for to determine whether it is linear or non-linear, you need to determine to determine what is your dependent variables. It is important for you to know what is your dependent variable. Okay, so for A, your dependent variable is f. So there is no multiplication of f with the derivative df over dx. So we pass the first condition. So next, moving to second condition, the derivative do not raise to power. So there is no df over dx to the power of any number. So we pass another condition. And for the last condition, check whether the dependent variable f are either linear or non-linear equation. So we don't have any non-linear f. So for A, we know it is a linear equation. Okay, so moving to B. For B, the dependent variable is y, the numerator. So dependent variable is y. Okay, for the first condition, the dependent variables and their derivative do not occur as products. But now you have d square y over dx square multiplied by your dependent variable. Because your dependent variable is y. So y multiplied by your derivative. So automatically this is a non-linear. Okay? Okay. For C, the dependent variable for C is, again, we have y. D square y d over dx square. Plus sin x plus y equal to sin x. The first condition, we pass the first condition because there is no y multiplied by dy over dx or d square y over dx square. But, okay, and then second condition, do we have any power of derivative? We don't have any power of derivative. So we pass second condition, but the last condition, the dependent variable y is, refer to this y, it is non-linear function. Because sin x plus y is non-linear. So because of this whole equation is non-linear. Okay. And d del cube y over del x cube. Again, your dependent variable is y. Okay. Plus x dy over dx plus cos square xy equal to 4x cube. Okay, first condition, dependent variable y multiplied by derivative. There is no such thing. So move to second condition, derivative do not raise to the power. Yes, we have no we pass the second condition as well. Okay, and then the third one, y must be linear. Again, this is y, a linear y. Okay, y linear. So we pass all the condition. So this is a linear equation. Okay, and last but not least, we have E. The dependent for E, we have x. D square x over dt square minus dx over dt square plus 3t dx multiplied by dt. Okay, so in this, obviously you know this is dx over dt to the power of 2. So it betrays the second condition. The derivative do not raise to power, but here the derivative raise to power 2. So it is non-linear. Okay. You have 3t multiplied by dx over dt, but now t is your independent variable. It's not dependent variable. So there is no problem with this term. Okay. So that's it for linear and non-linear. Oh, sorry. The last subtopic for this video is 1.2 first order differential equations. So the general form of the first order ODE is dy over dx equal to fxy. Fxy is two variable function. Okay, this is two variable function fxy. The classification of differential equations, we have four types of first order ODE. Okay, the first one, we have separable equations, linear equations, homogeneous equation, and exact equation. But for the syllabus, we will just consider these two equations, separable equation and linear equation. We will try to solve for these two equations. The first equation that will be considered in this syllabus, in this subject, is separable equations. So we have definition 1.1 here. If the function fxy, two variable functions of the first order differential equation, okay, we have df over dx equal to fxy, can be written as fxy equal to products of function x with function y. So we can say that it is separable. Okay, if we can split this ux and vy. Okay, so if it is separable, you need to solve for the separable equation. Okay, so basically we have three steps to solve a separable equation. The first one is obviously you need to separate the variable. So spread the variable y to the left hand side and x to the right hand side, or vice versa. Okay, the y can be, okay, and then the second step is to just apply the integration to both sides. Okay, just apply the integration sign, and then you need to solve for the integration for both sides. And the last step is to write your last answer in terms of this vy equal to ux plus c. Okay, that's the three steps. We have two examples in example 1.5. First, we have to determine whether the following differential equation is separable, and if it is separable, we need to solve the equations. So given dy over dx equal to 1 minus x squared over y squared. Okay, so start with the first steps. Okay, for the first steps, you need to separate the variables. Okay, so move your y to the left hand side and your dx to the right hand side. So you have y squared dy equal to 1 minus x squared dx. Okay, so this is the first step. And for the second step, you need to apply the integration. So you have y squared dy equal to 1 minus x squared dx. And then you need to do the integration to the both hand side. Okay, so integrate y squared, you have y cubed over 3 plus c1. c1 is the constant because you just do the integration for infinite integration, equal to integrate 1, you have x minus x cubed over 3 plus c2. Okay, and then move everything to the left hand side. Sorry, move everything to the right hand side except for y. So y cubed is equal to, move 3 to the right hand side, you have 3x minus x cubed plus 3c2 minus c1. Okay, and you can move to the last steps. Okay, for the last steps, y is equal to the solution. Y is equal to cube root of 3x minus x cubed plus 3c2 minus c1. Okay, then you just solve the equation. This is the last answer. For the second example, we have the initial value problem. Okay, let's say you have to solve the given differential equations with initial condition y2 equal to 0. So what does it mean by y2 equal to 0? So this means when x equal to 2, your y is equal to 0. 2 here is the value for x. Okay, and then y is 0. Okay, so you need to substitute this value into the solution. For dy over dx, you have y plus 1 over x minus 1. Okay, as usual, start with step 1. Okay, for the step 1, spread the variable. So dy over dx, y plus 1 over x minus 1. Okay, so for this one, you just move your y to the left hand side and move dx to the right hand side. So what you have here is 1 over y plus 1 dy equal to 1 over x minus 1 dx. And then second steps, do the integration to the both hand side. Dy equal to integration 1 minus x minus 1 dx. So integrate 1 over y plus 1 is equal to ln y plus 1 plus constant. Okay, and then for 1 over x minus 1, you have ln x minus 1 plus c2. Okay, now move this ln to the left hand side. So you have ln y plus 1 over x minus 1. This is the property of ln, logarithm. Okay, so you have c2 minus c1 over here. And again, to naturalize the ln, you need to multiply it by exponent. Okay, so apply exponent to the both hand side. So exponent ln will give you 1. So here you have 1 y plus 1 over x minus 1 on the left hand side, while for the right hand side you have exponent c2 minus c1. Next, we have y plus 1 equal to exponent c2 minus c1 multiplied by x minus 1. And for the last step, step 3, okay, step 3, you have y equal to exponent c2 minus c1 x minus 1 minus 1. Okay, but now you have initial value problem. So what you need to do is to add another step, step 4, to substitute the value for the initial condition. So for step 4, substitute x equal to 2 and y equal to 0 into this equation, solution y. So it becomes y equal to 0, and then exponent c2 minus c1, x is 2, so 2 minus 1 minus 1. So 0 equal to exponent c2 minus c1, 2 minus 1 is 1, minus 1. So exponent c2 minus c1 is equal to 1. Okay, so you find your constants, and then you need to substitute for the last answer. You need to substitute y equal to exponent c2 minus c1 is equal to 1. So substitute into this. Okay, so you have 1 multiplied by x minus 1 minus 1. So you have x minus 1 minus 1 equal to x minus 2. So the last answer is y equal to x minus 2. So if you have the initial value problem, your last answer will have no constant. There is no constant in your last answer. Okay. The next equations is linear equations. So before this, you know how to determine whether the equations is linear or non-linear. And if it is linear, you can solve the linear equation using these 5 steps. Okay, so we start with rewrite the equation in the form of this one. So you need to have your px, y, and then qx. Okay, rewrite the equation into this and determine what is your px and qx. Okay, it is important to know what is your px and qx. Second step is to determine the integrating factor. Integrating factor is equal to exponent integration of px from 1. Okay, step 1. And then the next steps is to write in a simple procedure. Okay, you multiply by integrating factor on both sides. So have d over dx ixy equal to ix qx. Okay, and for the fourth step, you need to do the integration. You apply integration to respect to x on the both hand sides, and then do the integration. And the last steps, as usual, you need to have y equal to x. You write your y in terms of x. So to understand better, we will solve example 1.6. First example, we have to find the general solution of 1 over 3 dy over dx equal to y plus 1 over 3 x squared exponent 3x. Okay, start with the first step. Okay, first step is to rewrite the equation in the form of, okay, you need to have dy over dx plus pxy equal to qx. So the first conditions is to make sure this 1 over 3 is equal to 1. So move this 1 over 3 to the right hand side. So you have dy over dx equal to 3y plus x squared exponent 3x. Okay, next you need to have your pxy. So so move 3y to the left hand side. So you have dy over dx minus 3y equal to x squared exponent 3x. So now, what is your p and what is your q? Px now is negative 3. Okay, do not include your y. So px is equal to negative 3. And your qx is everything on the right hand side. So x squared exponent 3x is your qx. Okay, settle first step. Second step, for second step, you need to find what is the integrating factor. To find integrating factor, you need to do the integration for px. So px is negative 3 dx. Okay, so exponent negative 3, integrate negative 3 respect to x, you have negative 3x. So your integrating factor is exponent negative 3x. You are done with second steps. So the third steps, what you need to do in third steps is to write just write d over dx and then substitute your integrating factor, exponent negative 3x. Do not forget your y, multiply by y, equal to your integrating factor, exponent negative 3x multiplied by qx. So qx is x squared exponent 3x. Okay, exponent 3x multiplied by exponent 3x. Exponent negative 3x multiplied by exponent 3x is equal to exponent 0. And always remember exponent 0 is equal to 1. Okay, always remember this. So this is equal to x squared. Okay, so next in step 4. In the step 4, you need to integrate both sides. So you have d over dx exponent negative 3xy equal to x squared. And then you need to apply integration respect to dx. Both sides. So dx. Look at the left hand side. You have integration. You have differentiation. So it will be cancelled out. Okay. So what left on the left hand side is exponent negative 3xy equal to x squared dx. And from here, you need to do the integration on the right hand side. So x squared, integrate x squared is x cubed over 3 do not forget your constant C. Okay, so that's it for step 4. For step 5, move your integrating factor to the right hand side. So you have y equal to x cubed over 3 plus C1. Moving your exponent negative 3x to the right hand side, it will become exponent 3x. So the last answer is y equal to 1 over 3 exponent 3x x cubed plus C1 exponent 3x. You are done. Okay, so this is the last answer. Okay, for the very last example in this video, we have an initial value problem. Okay, so solve the initial value problem. dy over dt equal to t exponent t minus y. With the initial condition y0 equal to 1. Okay, so for this one, you know it means when x equal to 0, your y is equal to 1. Okay, so start with first step. Okay, dy over dt. So your independent variable now is t. It's not x anymore. So you will have pt and qt. So dy over dt plus y equal to t exponent t. So automatically you know your pt is equal to 1. Okay, here you have 1 multiplied by y. So 1, and your qt is equal to this term, t exponent t. Second step, okay, second step, integrating factor it is equal to exponent integration of 1 dt, your pt. Okay, so you have exponent t, integrating factor. And the third step, just write d over dt, integrating factor exponent t multiplied by y equal to integrating factor exponent t multiplied by qt. Qt is t exponent t. Multiplication of exponential, exponent t multiplied by exponent t. So you have exponent 2t. Okay. Fourth step, integrate both sides. So integrate left hand side, you have exponent t, y. Okay. And then for the right hand side, you have t exponent 2t dt. Okay, now how to solve integration for a product of t and exponent 2t. So for this one, you need to know how to do tabular method. So for tabular method, you have differentiation part and integration part. So t will always be on differentiation part, while exponent 2t is always on integration part. Okay, do the differentiation until you get 0. So 1 and then 0. For integration part, exponent 2t becomes 1 over 2 exponent 2t. And then here you have 1 over 4 exponent 2t. Do not forget the sign, plus, minus, plus. And then products, cross product. Okay. So for the integration, you will have t over 2 exponent 2t minus 1 over 4 exponent 2t plus c1. Okay. Step 4. And for the last steps, move your exponent t on the left hand side to the right hand side. So y is equal to exponent 2t divided by exponent t. So you have exponent t minus 1 over 4 exponent t plus c1 exponent negative t. Okay. You have initial value. You have to solve for the initial value problem. So you will have another step, step 6, which you substitute the value of x equal to 0 and y equal to 1 into the equation in step 5. So now you have y equal to 1. Sorry, this is t. This is not x, this is t. Okay. So t equal to 0, y equal to 1. So 0 over 2 exponent 0 minus 1 over 4 exponent 0 plus C1 exponent 0. Okay, remember exponent 0 is always equal to 1. So 1 equal to 0 minus 1 over 4 plus C1. And you find what is your constant. The value for constant, it is equal to 5 over 4. Now you have your last answer without the constant. It is 1 over 2t exponent t minus 1 over 4 exponent t plus 5 over 4 exponent minus t. Okay? So that's it for this video. In the next video, we will discuss on how to solve first order ODE using numerical methods. Okay, thank you.